Welcome Pure Maths 1 students. I'm going to do a series of videos going over the exam questions and making some comments about where some weaknesses were and how we can improve. This is our prelim exam that we have just sat, and I know that there'll be some of you who are a little bit disappointed and think, oh well, you know, I can't really get any better between now and the exam. But that's not true. There's plenty of time between now and the exam if you are willing to work hard and to do lots of extra practice. As I mentioned at the beginning of the year, to achieve in this examination, you can't just do the classwork and leave it at that. You also need to do lots and lots of practice. And if you haven't been doing much of that up until now is certainly the time to get on to it. Okay. And of course, don't forget that we'll be doing, we've worked through functions, and a lot of you did reasonably well in functions, and we've worked through coordinate geometry and circular measure. We will work through integration and differentiation in the other subjects as well. So don't despair, keep working hard, and I'm sure we can make progress. Now, this is the first question that you had. Find the set of values of m for which the line with the equation y equals mx plus 1 and the curve with the equation intersect at two distinct points. Now, if they intersect at two distinct points, that means when we make them equal to each other, there must be two roots to the equation. Okay, so we're looking at something that perhaps looks like this, and then has, right, this and this. And we make those two equations equal to each other, the discriminant will give us two roots, so it'll have to be greater than 0. So let's just set that up. Here's our curve, 3x squared plus 2x plus 4, and we're going to make that equal to our line. This will give us the x values where they're equal. Now, I'm going to pull everything across. So my next line will look like this, 3x squared plus 2x minus mx plus 4 minus 1 equals 0. My next line will be 3x squared plus, and I guess we'll go 2 minus m into x plus 3 equals 0. Now, like I said before, we're going to use the discriminant. B squared minus 4ac has to be greater than 0 in this equation. So let's do that. That's going to be 2 minus m, because b is 2 minus m, and we're going to square that. Then we're going to go minus 4 times a, which is 3, times c, which is 3. Now, at first, I'm just going to set it equal to 0. What do we get? And then I will draw my diagram and find out the places where it is greater than 0. Okay, so 4 minus 2m minus 2m, so minus 4m, plus m squared minus 4 times 3 is 12. 12 times 3 is, so minus 36 equals 0. So I'm going to have m squared minus 4m and minus 32 equals 0. It looks like I can factorize this. It looks easily factorizable, if that's even a word. I need a minus 8 and a positive 4. So the value where they meet is m equals minus 4 or 8. Now we've got and now this is where a number of you went wrong. It says we have to have the set of values for which for which the line will intersect with two distinct points. And some of you just said, oh, m equals 4 or m equals 8. Now, that's not a set of values. So all of this is telling us is where the two equations meet. Okay, so at -4 and positive 8 x values, right? What we do at this point is we take this equation here and we sketch that. So we've got a crossing point here, got a crossing point here, and so you can see, hopefully it's going to be something like this. Yeah, this is x and y. That's my kids in the background. Okay, now we want, if we're wanting two distinct points, that means there's got to be two roots. So we want this equation here, we want it greater than 0. So where is it greater than 0? Well, it's greater than 0 here, or alternatively here. So we could finish off our answer by saying x is less than -4, or x is greater than 8. And that would be our answer to the first question. This time we're going to look at question 2. And let's just read this question carefully. The equation of the curve is such that, so our gradient function, dy dx, is equal to 3x to the power of a half minus 3x to the power of minus of a half. And it is given that the point 4,7 lies on the curve. Now remember, this here is our gradient function, not our curve. Our curve is going to be y equals something, okay? And this belongs to that. So just be careful with that. Okay. Well, let's get into it. If we're trying to find the curve given the gradient function, then we are going to need to integrate our gradient function. So we're going to integrate this. And it was a little bit disappointing to see a number of people forget how to integrate, given that this is a pretty key part of the course. So what we need to do is we take our 3, we raise the power of the x by 1. Some people reduce the power as if they are differentiating, which is a bit unfortunate. Then we're going to divide by 3 over 2. That's our first term. Now, the next term, we've got our 3x to the power of minus 1/2. We're going to raise the power, so it will now become 1/2. And then we're going to divide by 1/2. And then we will have a plus a constant. Now we're going to simplify this. We know that dividing by 3 over 2 is the same as timesing by 2 over 3. So we'll end up with 2 times 3 on top, and we'll have the 3 on the bottom here, x to the power of 3 over 2. A minus, and then dividing by 1/2 over here, that's the same as timesing by 2. So we can simply say that's going to be 6x to the 1/2 plus c. Now if we simplify this, we end up with 2x to the 3 over 2 minus 6x to the 1/2 plus c. This is what y equals. Okay, I should have probably written this y in here all of the time. Okay, now at this point we can take this and insert it into here to find c. So we're going to substitute in a 7 for y equals 2 bracket 4 to the 3 over 2 minus 6 into 4 to the power of 1/2 plus c. 7 equals, now 2. Now what's 4 to the power of 3 over 2? Well, it's like 4 square root, which is 2, to the power of 3, which is 8. So it's 2 times 8. Minus, and this one will be 6 times the square root of 4. The square root of 4 is 2. So 6 times 2 is 12 plus c. What have we got there? So we'll have 7 equals 16 minus 12, which is 4, plus c. So c equals 3. And then my last step is to write the equation of the curve. I shouldn't just leave it there. So y equals 2x to the power of 3 over 2 minus 6x to the power of 1/2 plus 3. And that would be the final answer there. When I look at some of the people who had problems with this, they had really forgotten their basic integration and forgotten how that worked. So my suggestion to all of you would be, particularly if you got this question wrong, to go back to the basics of integration and make sure you're reading the question. I had some people who read this question and decided that they already had the function, and they used the dy dx as the function and inserted things there. So make sure you're reading the question and don't lose your head. Alright, well, I'll see you next time.